Hey everyone, and welcome to another deep dive with us. Today we're going to get into something that causes, well, a lot of headaches in the manufacturing world.
Headaches is right. We're talking about short fill, and specifically short fill in die casting.
So if you've ever looked at, like, say, a part on your car or maybe your phone case or something, and there's just like this weird imperfection, like the metal didn't quite fill the mold all the way.
Yeah, it's like it's almost there, but just not quite. Drives you
Yeah,
nuts.
exactly. That's short fill. And we're actually diving into a really interesting expert report on this. It's way more common than you might think.
Oh, it's incredibly common. And what's fascinating is how deceptively simple it seems on the surface.
Right, you'd think, oh, just didn't get enough metal in there.
Right, you'd think it's that straightforward. But the causes, oh, they can get incredibly complex. It's a real puzzle sometimes for manufacturers to crack.
Okay, well, let's break it down then. Our source, they get into all these kind of culprits behind short fill. And the first one they talk about is all about how well, or not well, the molten metal flows. They actually use the term improper fluidity, which I kind of like.
Yeah, it's very technical,
Yeah.
but it makes sense, right? You're essentially trying to pour, what, molten aluminum into, say, the mold of a phone case, all those intricate little details.
Right, like those tiny little buttons and things.
Exactly. So if that aluminum isn't the right consistency, if it's too thick, too sluggish, whatever, it's going to have trouble reaching those fine points, and bam, short fell.
So, like, temperature is a huge factor in this then, right?
Uh.
I know our source emphasizes that if the metal isn't hot enough,
It's like trying to, I don't know, pour honey through a strainer in the dead of winter.
oh, I hate when that happens, haha.
It's just not going to happen smoothly, right? Same principle here. But it's not just the metal itself either. Imagine you've got your phone case mold, right? And the mold itself is too cold.
Oh, so the metal's cooling down too fast as soon as it hits.
Exactly. Solidifies before it can fully fill the mold. Nightmare scenario if you're trying to make a perfect part.
So temperature's huge, but then our source throws in another kind of curveball, impurities.
Oh, yeah, impurities. Those will get you every time.
Like even the tiniest little speck of something in that molten metal can cause a short fill, really.
Absolutely. Think of it this way. Imagine you're making a piece of jewelry, a really delicate earring with like a fine, intricate design. Yeah.
Okay, I'm picturing it.
Now, imagine a tiny speck of dust, just a tiny speck, gets lodged in the mold. That little speck creates a bump. Yeah, the metal flows around it, leaves a void, short fill, ruins the whole piece.
Wow, so we're talking like microscopic stuff here that can have a big impact. And speaking of things that can throw a wrench into the process, our source also mentions pressure problems.
Right, because pressure is key to getting that molten metal where it needs to go. Too little pressure, and it's like trying to, fill up a tire with a hole in it.
You can pump all the air you want, but it's never going to inflate properly. I've been there.
And then on the flip side, too much pressure. That's a whole other problem, like trying to squeeze way too much toothpaste out of the tube at once. You'll make a mess, or worse, break the tube. In die casting, that translates to damage, defects, all kinds of headaches.
So it's all about balance, finding that sweet spot.
Exactly. Like so many things in life, it's about finding that delicate balance.
So I've got all these factors at play, and we know even with the best intentions, things go wrong, and we end up with, dun dun dun, a short fill. So what happens then? Is it a big deal or just a cosmetic thing?
Well, that's the thing. It can be both. Cosmetic, yeah, sometimes. But other times, it's a real problem. Depends on, I guess, how bad the short fill is and where it is on the part itself.
Okay, so like location, 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 right?
Exactly. Think about it like, I don't know, a scratch on your car, right?
Okay, I like where you're going with this.
Tiny little scratch in the paint. Annoying, sure. But doesn't really change how the car drives. But a huge dent right in your line of sight. Or on like a crucial part, That's different.
Yeah, that's going to affect how the car functions.
Exactly. And our source really hits on this idea that short fills, they're not just about aesthetics. A bad short fill can actually weaken the entire part.
Making it more likely to, what, break or something under stress?
Exactly. If you've got a short fill in, say, I don't know, a load-bearing part of a car chassis.
You're talking about some serious stuff now.
Yeah, over time, all the stress, the vibrations, whatever, it concentrates around that imperfection. And then, boom, crack. Huge safety issue.
Okay, so this is not just like, ooh, that doesn't look very nice. We're talking about the actual integrity of the part.
Exactly. And this is why understanding the impact is so important, right? Especially in industries where you absolutely have to have reliability.
Right, like you don't want your airplane wing having a short fill, that's for sure.
Yeah.
Okay, so we've established short fills, not good. But before we all panic, let's talk solutions. Our expert source, they actually give us a bunch of ways to prevent this stuff, like a whole checklist for die casting success.
And it all starts with the basics. You got to make sure that molten metal is as pure as you can possibly get it. That means proper smelting, getting rid of any impurities, any little thing that could mess with the flow.
Our source actually says cleanliness is key. Kind of love that.
It's true, though. Like, imagine you're baking, right? You wouldn't start making a cake without cleaning your mixing bowls first, would you?
Well, I might, but I wouldn't want to brag about it. But good point.
So clean metal, that's number one. And then, of course, we got to talk about temperature again.
Ah, yes, the Goldilocks variable. Not too hot, not too cold.
You got it. It's about finding that sweet spot for both the molten metal and the mold itself.
Because we don't want that metal solidifying too fast.
Exactly. And every metal, every alloy, even every mold design, it's going to have a slightly different ideal temperature range. Our source, they actually give some specific numbers, which is super helpful.
So we're not just talking in vague generalities here. This is actionable advice. Okay, so we've got clean metal, we've got the temperature dialed in. What else can we do to prevent these pesky short fills?
Well, this is where the actual design of the mold comes into play and something called strategic gating.
Okay, now that one sounds a little intimidating. Break it down for me.
Basically, it's like, imagine you're designing a water slide, right? For the molten metal. You want a nice, smooth ride from the melting pot all the way into every corner of the mold.
No sudden stops or unexpected turns.
Exactly. The gate, that's the entry point for the metal. And the size, the shape, the placement of that gate, that all affects how smoothly the metal flows.
So it's not just about getting the metal in there, it's about guiding it with precision.
Exactly. I mean, for simple shapes, a basic edge gate where the metal flows in from the side, that might be fine. But for more complex designs, you might need a sprue gate where it comes in from the top, or even multiple gates for really intricate parts.
So different tools for different jobs, just like any other skilled profession.
Right. And as important as it is to get the metal in, we got to make sure the air can get out. Ventilation.
Oh, right, those little vents or channels in the mold itself.
Yeah, like those little holes they put in coffee cup lids now.
Yeah.
Let the steam escape.
So you don't get a pressure buildup and end up burning your coffee.
Yep.
I get it.
Same idea here. Those vents, they allowed trapped air and gases to escape as the metal flows in. Prevents air pockets, which, yep, can cause short fills.
Okay, that makes sense. So the mold itself has to be designed really thoughtfully.
Huge part of it, yeah. And you know what one common design flaw is that can lead to short fills?
Hit me with it.
Inconsistent wall thickness. Imagine trying to pour, I don't know, pancake batter into a pan that's got all these weird bumps and dips in it.
It's going to pool in some areas and be super thin in others.
Exactly. Same principle with die casting. You want that nice, even wall thickness all the way around. Promotes that smooth metal flow.
Okay, so consistent thickness is key. What else? What about those computer programs, the CAD software? I know those are used a lot now in mold design.
Oh, it's been huge, absolutely. CAD software, it's like having X-ray vision for your molds.
Oh, I like that. So you can catch those potential problem areas before you even start pouring metal.
Exactly. And not just CAD, but simulation software, too.
Oh, right. Like having a virtual die casting foundry right on your computer screen. We touched on that a bit before.
Right. And this is where things get really cool. You can create a digital twin, essentially, of your entire casting process. Input the mold design, metal type, temperature, pressure, everything.
And then you hit go and cross your fingers.
Pretty much. But the cool thing is, you can run that simulation as many times as you want, tweak different variables each time, and see what happens.
If you're thinking about trying a different gating strategy or messing with the mold temperature,
Yeah.
you could test it out virtually first without wasting any actual metal.
Exactly. It's all about finding that optimal setup.
Like having a crystal ball for your casting process. See into the future, prevent any mishaps. This is cool stuff.
Oh, it's revolutionizing the industry. It really is. But, you know, even with all the best technology, all the fancy simulations, we still need to talk about something pretty low tech, but so crucial.
Okay, I'm intrigued. Hit me.
Lubricant?
Lubricant. Wait, like WD-40?
Well, not exactly, but you get the idea. In die casting, we use what are called mold release agents. They create a barrier between that super hot metal and the mold surface.
Okay, so it's like greasing a pan before you make a cake, right? Prevents things from sticking.
Exactly. It's all about that smooth release.
So we're talking about getting those nice, clean, mirror-like finishes, right?
Precisely. But as with many things, too much of a good thing can be bad. Too little lubricant, Metal sticks, you get defects, too much lubricant, you can contaminate the molten metal, change its properties.
The Goldilocks principle of lubrication.
You got it, that perfect amount every time. It's what separates the pros from the amateurs, you know?
This is blowing my mind, honestly. I never realized how many little details go into making these parts that we just, like, take for granted.
Oh, it's a whole world hidden in plain sight.
So we've talked about how to prevent short fills, but I'm curious, like from a real-world perspective, can you give me some concrete examples? How do these flaws actually show up, say, in the automotive industry?
Oh, sure. Cars are a great example. Think about, when you open your car door and you notice that the gap between the door and the body of the car, it's just a little bit off, not quite even.
Or maybe like a weird bump or imperfection on the dashboard where it looks like, something went a bit wrong.
That's it. Those could be signs of a short fill during the manufacturing process.
So even if it doesn't actually affect how the car works, it still impacts the aesthetics.
Exactly. And let's be honest, looks matter. Especially in a competitive market, consumers notice those little imperfections.
First impressions are everything, as they say.
Exactly. And it's not just cars, right? Think about electronics.
Oh, yeah, smartphones and laptops and all that.
Those things are so sleek, so precise, and a lot of those casings die-cast.
Really? I didn't realize that.
Oh, yeah. So imagine you've got a tiny short fill on the edge of your phone case. Might seem minor, right? But it could affect how well that case protects your phone if you drop it.
Or like if the short fill is near a button or a port, it could mess with the functionality.
Exactly. And these days, those kinds of flaws, they end up online. Bad reviews, social media rants, the whole 9 yards.
Yeah, that's not the kind of publicity any company wants. So it sounds like no matter what industry we're talking about, preventing short fills is crucial.
Absolutely. And the good news is, with the right knowledge and a little bit of ingenuity, it's totally achievable.
Which brings us back to all that good advice from our expert source. We covered a lot, from the importance of clean materials to strategic gating to those little vents that prevent air pockets.
It's all connected, right? It's like this intricate dance. Every step has to be perfect.
Well said. Okay, so we've talked about the problem, we've talked about the solutions, but I'm always curious about the future. Are there any new technologies or techniques on the horizon that could, completely change the game when it comes to short fill prevention?
Well, technology is always advancing, so I imagine researchers and engineers out there, they're not just resting on their laurels, right? There's got to be some cool stuff in the pipeline.
Oh, absolutely. This is a field that's constantly evolving. And one area where we're seeing some really exciting advancements is in real-time process monitoring and control.
Okay, so like more sensors, more data. We're talking about Industry 4.0 type stuff here.
Exactly. Imagine sensors embedded right in the mold itself. They're constantly measuring things like temperature, pressure, even the way the molten metal is flowing in real time.
So it's like giving the mold a nervous system almost. It can sense and react to what's happening inside.
That's a great way to put it. And here's the key. That data isn't just being collected. It's being fed into a control system. And that system can make adjustments on the fly. So let's say, I don't know, the sensors pick up a sudden temperature drop in one area of the mold.
Right. The control system sees that and says, uh-oh, that's not good. We need more heat over there. And boom, it automatically increases the heat flow to that specific spot. Prevents the metal from solidifying too quickly. You avoid a potential short fill.
It's like having a co-pilot for your die casting process, always making those tiny corrections to keep things running smoothly.
Exactly. And the benefits are huge. Fewer defects, less waste, higher quality parts overall. It's a win-win.
So we're not just talking about, like, fixing problems after they happen. We're talking about predicting them before they even start.
Now you're getting it. And this is where things get even more futuristic. Artificial intelligence, machine learning. Imagine all that data from those sensors, all those millions of data points. We feed it all into a learning algorithm.
Okay, so the AI, it starts to see patterns. It's learning from past casting cycles, right?
Exactly. So it might pick up on this subtle shift in the metal's viscosity, something a human operator might not even notice. But the AI, based on all its data, all its experience, it says, hold on a second, this is what happened last time, right before we had a short fill.
And then what? Does it send out an alarm, flashing red lights?
It could. Or, even cooler, it could actually adjust the process parameters itself, tweak the pressure, change the temperature, whatever it needs to do to head off that short fill before it even has a chance to form.
It's like having a die casting oracle. Sees the future, guides us toward the perfect outcome. I love it.
It really is amazing when you think about it, and we're only just scratching the surface of what AI can do in this field.
It's mind-blowing. And, I think this is a perfect example of how artificial intelligence, it's not just some abstract concept. It's got real-world applications. It's solving real-world problems right now.
Right. And I think this is only the beginning. As materials science advances, as we demand more complex parts, more intricate designs,
Hmm.
the technology is only going to get more sophisticated.
It's an exciting time to be following this industry, that's for sure.
Absolutely. And it makes you appreciate, I think, all the work that goes into even the most seemingly simple objects we use every day.
Well said. Well, on that note, I think we've reached the end of our deep dive for today.
A deep dive into the surprisingly complex world of short fills.
Exactly. So, to our listeners, next time you pick up your phone, or you open your car door, or you use any kind of tool or gadget, take a moment to think about all the incredible engineering and precision that went into making that object. And maybe, just maybe, you'll have a newfound appreciation for the quest to eliminate those pesky little short fills.
And who knows, maybe some of our listeners out there, they'll be the ones coming up with the next big breakthrough in die casting.
That's it for us. Thanks for joining us on another deep dive, and we'll catch you next time.